Hi everyone, today I present the paper named Quality-Agnostic Deepfake Detection with Intra-model Collaborative Learning. And I am Ben. My supervisor is Simon Wu. We are from Sungkyunkwan University from South Korea. Our presentation includes introduction, methods, experimental result, and conclusion. The motivation, as we know that the deepfake is become popular in recent years, and there are also various detection methods based on different artifacts of the video. However, most of them develop dependent detection model for different qualities, and it introduced considerable computational overhead. In this work, we introduce a novel framework named Quality-Agnostic Deepfake Detection (QAD), which can capable of detect defect across quality and offer enhanced overall performance. And this is the illustration of our motivation. For the contribution, in this paper, we introduce a theory that establishes the connection of classification error and the similarity of the intermediate representation of the high and low quality. We introduce a comprehensive novel framework that's comprised of 2 novel modules, and finally we perform extensive experiments on 7 datasets. Let our notation in this paper as following, including the raw and the compressed version of the image, the training dataset, our learning framework F, and the loss function F. And we consider the loss function in very simple notation. Our theory, you can visit our paper to see its proof. So for simple, we minimize the expectation error by minimizing the classification error and the collaborative loss. This is the expectation error. This is classification loss of the compressed version image, and this is the instant-based collaborative loss. We try to apply the adversarial way perturbation to robust model to the compressed to the corruption of the input. And for instant-based collaborative loss, we apply the Hilbert-Smith independent criterion to ensure the geometrical similarity of the raw data and the compressed data. This is the overall illustration of our framework. For the training dataset, we apply the H264 codec to introduce the compressed version of the datasets. We then forward to the single model which set the same parameter and apply the Hilbert-Smith independent criterion at the intermediate filter and the adversarial way perturbation at the output. For adversarial way perturbation is similar with the adversarial applied on the input image, but here is applied on the model way. For the Hilbert-Smith independent criterion, it measures the dependency between the 2 random variables u and v via the kernel case, and a minibatch including 2 quality tau and pro in the layer L are expressed in the following loss functions. So our overall training loss for the minibatch B including M quality modality. This is spread at the following. And the alpha is high parameter to balance the contribution of this loss function. In the experiment, we experiment with 7 datasets, and on the 2 compressed version beside the raw quality dataset. Also, we apply on the backbone of ResNet and EfficientNet B1. We compare our model with a baseline. The first one is quality agnostic, which means the baseline model doesn't know the input quality. We test our model on both video compression and random JPEG compression image. In both of the case, our model can perform the state-of-the-art performance across the setting. In the quality aware, which means the baseline knows the input quality except our model. We can see that our model with the EfficientNet B1 attain the state-of-the-art performance with the smallest number of parameters with the knowing of the input quality. We also study the combination of different collaborative loss and adversarial loss, and our choice present the best performance. We also study the hyperparameter in our loss function, and finally we study the distribution of the penultimate representation with and without our model. You can see that with our model, the QAD representation are less dispersed in both of intra-class and inter-quality. In the conclusion, in this paper, we propose a universal single defect detection framework called QAD that utilizes the adversarial wave perturbation and Hilbert-Smith independent criterion. Our experiments show that our proposed method can achieve the competitive performance with the prior knowledge of the input image quality. We would like to express our acknowledgement to the Korean government for grant funding for this paper. And we thank you for your listening.